The question is, evaluate x plus 2 upon square root of x square plus 2x plus 3 dx. Now to solve this question, first of all we look at this given integral. It is in the form of a linear term upon the square root of a quadratic term in the variable x. Okay, so to integrate such problem we are going to write this numerator x plus 2 as equal to lambda times d upon dx of the term in the denominator, that is in the square root of the denominator, that is x square plus 2x plus 3 plus mu. Okay, and we have to calculate for the value of lambda and mu. Okay, now this x square plus 2x plus 3 on differentiation gives me 2x plus 2. So I can write x plus 2 is equal to lambda times 2x plus 2 plus mu. Okay, on separating the terms of x and the constant term in the right hand side, I get the expression like this. Now, in the left hand side, the coefficient of x is 1, and in the right hand side, the coefficient of x is 2 lambda, right? 2 lambda multiplies with x, so coefficient of x would be 2 lambda. So I can equate them. So on comparing the coefficient of x, I get 1 is equal to 2 lambda, or lambda is equal to 1 by 2. This is my equation number 2. Okay, so on comparing the constant term, in the left hand side I have 2, and on the right hand side I have 2 lambda plus mu. So equating, I get 2 is equal to 2 lambda plus mu. That is my equation number 3. Okay, now to calculate for the value of mu, I am going to place 1 by 2 in this equation to get 2 is equal to 2 into 1 by 2 plus mu. This cancels out to give me 1. So I get 2 is equal to 1 plus mu, or mu is equal to 1. Now I'm going to place the value of lambda, that is equal to 1 by 2 here, and mu is equal to 1 here in equation number 1 to get this equation number 1a, right? Now this value I'm going to substitute in place of x plus 2 in the given integral. So I'm going to obtain 1 upon 2 into 2x plus 2 plus 1 upon square root of x square plus 2x plus 3. Further, what I'm going to do, I'm going to divide the denominator separately by these two terms in the numerator. So I get the integral like this. So I obtain two integrals. I'm going to solve them separately. Both of them cannot be solved directly also. So I'm going to name them I1 and I2, right? Now, taking I1 is equal to 1 by 2 times 2x plus 2 upon square root of x square plus 2x plus 3. Okay, now differentiation of x square plus 2x plus 3 is equal to 2x plus 2. Therefore, I am going to substitute x square plus 2x plus 3 as equal to t. Differentiating with respect to x, both sides, I get 2x plus 2 dx is equal to dt. So I'm going to replace 2x plus 2 dx with dt. 1 by 2 is written outside, and this as square root of t. So I have to obtain the integral like this, or this can be written as 1 upon 2 times integration of t to the power of minus 1 by 2 dt. This can be integrated by using the formula of integration of x to the power of n, that is x to the power of n plus 1 upon n plus 1 plus c. So this is equal to 1 by 2 times t to the power of minus 1 by 2 plus 1 upon minus 1 by 2 plus 1, which is equal to 1 by 2 times t to the power of 1 by 2 upon 1 by 2. These two terms cancels out to give me root t, and instead of t I can write x square plus 2x plus 3. So I get the integration, or I1, as equal to x square plus 2x plus 3. Okay. To solve the value of I2, first thing what I see here is this, that is integral is in the form of 1 upon square root of a quadratic expression x square plus 2x plus 3. So to solve this, I am going to write this quadratic expression as the sum or the difference of a variable term in form of a square and a constant term in a form of a square. Okay, let us see how we are going to do this. So taking x square plus 2x plus 3, the coefficient of x square is 1. So I'm going to take half of the coefficient of x, that is 2 upon 2, 1, and add and subtract to this expression. So I'm going to get this as x square plus 2x plus 1 square minus 1 square plus 3. Right? This can be written as x plus 1 whole square, and this can be written as 2. Okay, and further I'm going to write this 2 as square root of 2 whole square. So I've converted this in as the sum of a square of a variable term and a constant term. Right? This I'm going to place instead of x square plus 2x plus 3. So I obtain I2 as this much. Now to solve this further, I'm going to substitute x plus 1 as equal to t. Differentiating both sides with respect to x, I get dx is equal to dt. So dx I'm going to replace by dt, and x plus 1 whole square with t square. Right? So this will be equal to 1 upon square root of t square plus root 2 whole square dt. Now I know that integration of 1 upon square root of x square plus a square dx is equal to log of x plus square root of x square plus a square. So applying the same formula here, I am going to get this as log of t plus square root of t square plus root 2 whole square. Replacing the value of t, I am going to get log of x plus 1 plus square root of x plus 1 whole square plus root 2 square. This value is equivalent to x square plus 2x plus 3. So replacing, I get I2 as equal to this much. Okay, now taking the value of I1 and I2, we had to integrate the function x plus 1 upon square root of 4x minus x squared dx. This was written as equal to two integrals I1 and I2. Replacing the value of I1 and I2 as square root of x squared plus 2x plus 3 plus log of x plus 1 plus x squared plus 2x plus 3 plus c, I get the required answer. So this is how I'm going to solve this question. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.